In this unit, we're going to cover two primary topics, file and storage. So file management and storage management. And we'll talk about some of the advanced services that are available in these areas. So first, we're going to start with file services. And we're going to talk about a couple different things. We're going to talk about branch cache, file classification infrastructure, file auditing, and the network file system, or NFS. So let's start with branch cache. So basically, branch cache is a service available in Windows 2008 and newer. It allows you to cache files, shared files, in a branch office. That way it increases the performance when sharing files across slower WAN links. So basically, you would configure basically an SMB share, and you can actually do this with a couple different services in Windows. I'll talk about this, but basically you take a cache of files that are at the central site, and you can use branch cache to extend that and cache them at another facility. And there's really a couple different ways to do this, but it works with the file server role, web server role, and the background intelligent transfer service, or BITS feature. So those three you can use this with. So file server, web server, and background intelligent transfer service. So you can host files and use branch cache with those three services. So it has two modes of operation. The first is distributed, and the second is hosted. So with distributed, you don't have to install anything at the branch office. It uses existing clients in Active Directory to store those files. So basically, you can almost think of it as like BitTorrent, like peer-to-peer file sharing, right? Where everybody stores parts of files or portions of files on their own computers. There's no central data store for something like BitTorrent, right? Although a lot of people don't use BitTorrent anymore, but I think most of you are probably familiar with that. But that's how the distributed mode works. And then hosted mode is where you have a centralized server at the branch office that hosts the file centrally, as opposed to them being distributed across all the computers. So those are the two modes of operation. You can only use one at a time at each branch office. So once you choose one of those modes of operation, you have to continue using that mode at that particular location. So here you can see we have one branch office on the bottom that's using distributed mode, and the branch office at the top is using the hosted mode. So the reason you would use distributed cache mode is it's great when you don't already have server infrastructure at the branch office. So you have a small branch office that there's no servers there, there's no domain controllers, there's no real infrastructure other than the workstations. You don't want to have to install additional servers and maintain them and all those sorts of things. So you could just use distributed mode in that case, and it'll probably be fine for an office like that. Whereas if you already have some server infrastructure in, say, a larger branch office, then in those cases it would make sense to go with the hosted cache mode. So you can switch to the hosted cache mode if you want to increase the availability, because you have a lot of different users in that branch office that are going to be using those files, and or if you have multiple subnets. And again, it's a little more efficient, and you already have server infrastructure in place. So changes to files. So this is one of the problems when you cache a file. What happens when you change the file on the server side? That somehow has to notify the branch cache client side at the branch office. So there's two versions. The version that works with Windows 7 and 2008 R2 is version 1. And the problem with version 1 is it requires you to retrieve the entire file, starting with the part that changed whenever there's a change. So a lot of times you're re-downloading or re-caching the entire file. Whereas with version 2, which is natively supported in 2012 and later, as well as Windows 8, so that would work with Windows 10 clients, with version 2, it only has to get the part of the file that changed. So you only have to get smaller payload when a portion of the file is changed. It only has to get that portion. So it makes it a little more efficient in that case. So that's basically branch cache. So it's a pretty useful feature. And this will help make storage a little bit more, or file access, I should say, much more efficient with remote offices. And here are some of the protocols that are supported with branch cache, which are listed in your textbook. So to install the role, just like any other role in Microsoft Windows, you're going to go into File and Storage Services, and you'll find branch cache listed in that list of services. And then when you do that, you'll have some additional options, like setting up the hash publication, for example. You have the support tag for each shared folder that should be cached, so you have to tell it which shared folders you want to cache. And then you have to install, if you're going to use IIS, you have to run the PowerShell commandlet to install the feature for branch cache for IIS. Let's see, and you can also configure a server for hosted cache mode. So if you're going to use a server for hosted cache mode, where we install that server at the remote site, you would have to install the branch cache feature using add roles and features, or you could use the PowerShell. You install the certificate for that's trusted by the branch office client computers. So you would have to, just like you would install a SSL certificate for HTTP. This is if you're going to be using IIS and the web server for branch cache. And then we configure your branch cache clients to use the branch cache in hosted cache mode. And this is where you would configure that in the client operating system. So you do have to set up both the client and the server for this to work. There are some PowerShell commandlets that you can use to manage branch cache. This is the list. It's also enumerated in your textbook, and you can review that in your textbook as well. The next service that we're going to talk about for file services is file classification infrastructure, which allows you to classify files by assigning new properties to them. So this allows you to create ad hoc properties for files, which is useful for adding additional metadata to files. So this allows you to add more metadata to files than what's available natively in Windows or in the file header itself. So file classification management involves 3 steps. You're going to create file classification properties. Then you create file classification rules to apply classification properties to files and folders. And then you carry out file management tasks based on the classification of those files. So to classify files, you have to install the File Server Resource Manager, which is a role under File and Storage Services role, which we saw a few slides ago. Then you're going to create classification properties that are applied by using classification rules. And then the classification property is a file attribute containing a value that's used to categorize data in a file. So any aspect of a file can be classified. So you can, when we say classification, it's sort of categorizing, right? It's putting metadata tags on the files so that you can track them, and you have additional metadata for searching and for sorting and understanding the data that you have, and creating additional rules with other services later on, such as auditing file access. So you can also add additional roles and services for auditing file access, and you can use this to target specific files and users in audit policies to reduce the volume of auditing information that's logged. Auditing can use a lot of storage space, so you can sort of target exactly what you're interested in auditing. You can combine global access auditing with dynamic access control, or DAC. We haven't talked about DAC yet. We're going to be talking about that in the next unit when we cover IPAM and DAC. But for right now, when we get to DAC later on, you'll see how I'll talk about DAC and how that can use file classification services as well as auditing file access. And data access events contain more information. So more information to audit. You can audit removable storage devices to increase security. Again, this would be for things like data leakage protection, or DLP. So Windows, of course, has some features that help us manage DLP policies. And this is the dialog box that you'll use to configure that. I believe in the lab you're going to do this. You're going to set up auditing in the lab. So global object access auditing allows the administrator to manage auditing centrally by using group policies. So it affects the entire file system in the registry on computers in the scope of the GPO where the policy is defined. You can narrow the criteria for triggering audit events by using a condition with resource properties, again, which can tie back to file classification. Finally, we have the network file system. So if you think back to our previous, in the class that you took before this one, we talked about Windows Server 2012. I covered file services in Windows, and normally when people think of file services in Windows, they think of SMB, or the Server Message Block Protocol, which is how you use a UNC path to access a file in a Windows network, which is the native method of doing file sharing in Microsoft Windows. In the Linux world, in the Unix world, they don't use SMB by default. They use NFS. So Microsoft can support NFS, and this is the role that supports that. So there's both a server and a client component for supporting NFS. So this is usually for compatibility with Linux and Unix systems. And a lot of administrators, when I'm teaching this class in person, face-to-face, they'll say, well, why do I care about Linux and Unix machines? Because, I'm a Windows network when I'm installing Active Directory. I have this Active Directory ecosystem. All I care about is my Windows clients. We'll just install Samba or something on the Linux machines. And I'll give you 2 reasons that this is really important now. The first reason is with Linux and Unix computers are becoming more popular on SCADA type systems. So you have a lot of different environments now that have to support non-Windows systems. So such as building automation, controls, devices, all these things that are running embedded Linux operating systems that may need file sharing services on the network. You're not going to be able to install SMB or Samba on a lot of those devices. So that's the first challenge. And then the second challenge is mobile devices, right? So everybody has these bring your own devices that they want to use. Again, they're not going to support Samba by default, but a lot of them will support NFS. So a couple of good reasons for us to support NFS. Now there's kind of a catch-22 here because with NFS you have to also install a client in Windows. So it works great with Unix and Linux systems because it works natively with Unix and Linux, but it doesn't work natively with Windows. So if you want to access files with NFS from a Windows client, you have to install the feature for NFS on the client side and configure it to access those files. So again, it's very similar to Windows file sharing, but it's native to Linux, Unix, and you have to install the client for Windows in order for it to work. So you'll install that from the file services role. You can also use failover clustering, so you can do clustered, for high availability for NFS, for example. So these are some of the PowerShell commands for managing NFS. And in the next slide deck, I'm going to show you how to configure some advanced storage or file storage services in Microsoft Windows.